In this lesson, we will be learning how to graph linear equations. As we have discussed linear equations in two variables, graph as a line in the coordinate plane. The variables must be in separate terms and to the first power. Let's look at some examples of equations and determine if they are linear equations. Y equals 3x. Has two variables that are both to the first power and in separate terms. Yes, it is a linear equation. 2x plus 4 equals 22 is also a linear equation. 3xy equals 15. The variables are to the first power, but they are a product. They are not in separate terms. Therefore, that is not a linear equation. X squared plus 5 equals y. The x term is not to the first power. Therefore, it is not a linear equation. X equals y is a linear equation. They are both to the first power, and they are not in the same term. As we graph our lines, remember that you want to have your equation in y equals form, which means the y should be on the left side of the equation and everything else on the right side of the equation. Please remember to use graph paper, a straight edge to draw all lines, graph them accurately. The axes in the line that you graph should all have arrows at the end, and the axes should be labeled X and Y. Now let's look at our first example. We want to graph y equals x plus 6. Well, let's make a table and then plot the points. For this table, I have selected values of -6, -4, -2, and 0 for the values of x. Plugging each of those into the equation, we can see what we get for the values of y. If we put -6 into the equation for x, y comes out to 0, and so forth. So our coordinate points that we're going to graph are -6, 0, -4, 2, -2, 4, and 0, 6. And there you have a graph with those 4 points plotted. And we will use a straight edge to draw a line through those 4 points. If you have done it correctly, all of the points should line up along one line. Let's look at another example. Y equals 1/2 x minus 7. For this equation, I have chosen an x to be 0, 2, 4, and 6. You do not need to choose the same points that I choose. You will learn with experience what some good points are to choose for a given graph. Evaluating each of those values of x, we get the coordinate pairs 0, -7, 2, -6, 4, -5, and 6, -4. You do not need to list those in as ordered pairs if you were just graphing and the directions do not say otherwise. Now we have graphed those 4 points, and we see that they do appear to make a line, and we draw a line with a straight edge through those points. Let's consider one more. Y equals -2x minus 3. I have chosen 4 values of x, and I have filled in the table with the values of y. And here, those 4 points are plotted and connected with a line. Now, as you look at this graph, Do you notice anything different about this graph compared to the previous two graphs that we did? The previous graphs that we did had lines that sloped in this direction. This graph slopes in the opposite direction. We will learn more about the slopes of these graphs and why some go upwards to the right and some go upwards to the left. This sign in front of that x term will be the key that we will be looking at in the next lesson. Here is a practice problem for you to try. Graph this linear equation. I hope you got this result. Now we need to look at two special cases. Consider the following equation, y equals -3. Is it a linear equation? Well, it doesn't look like it is an equation in two variables. However, we could consider that it has a 0x. Since we are working in a coordinate plane, let's think about this question. For what value of x is y equal to -3? Yes, I realize there is no x in that equation. So no matter what I pick for x, let's look at the table. I've picked -2, 0, 3, and 4. No matter what I pick for x, y is going to be -3 because y is not affected by the value of x. Now let's plot these points and make a line. We have -2, -3, 0, -3, 3, -3, and 4, -3. And those 4 points do, in fact, exist on a line of y equals -3. It is a special line, and it is a horizontal line. Whenever y is a constant, we have a horizontal line in the coordinate plane. Now we need to consider one more special case. It is when x is equal to -2. Consider a similar question. For what values of y is x equal to -2? We're going to make a table again, but this time we're going to select values of y. No matter what I select for y, x is going to be -2 because x is not dependent on y. Now let's plot those points. And we can see we have a vertical line. When x is a constant, we have a vertical line. So we have now covered the two special cases of a vertical line and a horizontal line, both of which are linear equations if you graph them on a coordinate plane.